This question gives a bunch of information, but at the bottom of the question it says, calculate the wavelength of the line in the emission line spectrum of hydrogen caused by the transition of an electron from n equals 3 to n equals 1. And then it says to round to 3 significant figures. To do this, you want to use the Rydberg equation. And the Rydberg equation is delta E, the change in energy, equals the Rydberg constant times 1 over nf squared minus 1 over ni squared, where nf is the final energy state and ni is the initial energy state. And much like in thermodynamic equations, thinking about whether this is negative or positive is better to be thought about from what's going on than from the math, because if you accidentally switch these, you'll get the positive answer. In this case, you have a transition from 3 to 1. That's an emission. So if the atom is the system, the atom must lose energy when the electron goes down, and it loses that energy in the form of a photon. Now we can just plug into this equation. Delta E equals the Rydberg constant, 2.18 times 10 to the minus 18 joules, times 1 over the final NF, which is 1 squared, minus 1 over the initial state, 3 squared. So basically you have 1 minus 1/9, which is negative 8/9. And when you do the math, you find that the change in energy equals negative 1.93778, and some more numbers, times 10 to the minus 18 joules. And technically, since the Rydberg constant is a measured number, that it will have 3 significant figures. However, the question doesn't ask us for the energy of the photon. It asks us for the wavelength. And we can use the equation E equals hc over lambda. Because remember, if you know the wavelength, you can calculate both the frequency and the energy. When we rearrange this equation, we find that lambda equals hc over E. So, plugging in, lambda equals h, which is Planck's constant, 6.626 times 10 to the minus 34 joule seconds, times c, 3 times 10 to the 8th meters per second, divided by E as a positive number, because you can't have a negative wavelength. A wavelength is a distance. This is not actually a negative amount of energy. This is just saying that the atom is losing energy. That's why it's negative. But this is the actual magnitude of this energy, of course, is positive. So we plug this in as a positive number, which is 1.93778 times 10 to the minus 18 joules. In this case, we find that lambda equals 1.03 times 10 to the minus 7 meters. However, it often likes the answers to be in nanometers, and in fact you would speak about this wavelength in nanometers, so you could multiply this by 1 times 10 to the 9, 1 billion, and you would find that it's 103 nanometers. So 103 nanometers is the wavelength of this light. That is ultraviolet light.